Welcome to the channel. I'm Carlos Ortega, and I'm excited to explore the amazing worlds of physics and chemistry with you.
Think about the last time you roasted a marshmallow over a roaring campfire. You feel the metal rod burning in your hand, you watch the hot smoke rising into the night sky, and you feel an intense, dry glow baking your face. You are sitting in front of a single heat source, yet the energy from that one fire is physically attacking your body in 3 completely different ways, all at the exact same time. In everyday life, hot and cold are sensations. In science, they are precise quantities governed by the laws of motion. Take a look at this animated diagram. Temperature is strictly a measurement of the average kinetic energy, which is the speed of motion, of the atoms and molecules inside a specific system. As the vibrational speed of these clustered molecules increases, the digital temperature readout rises right alongside it. What we actually feel as heat is this kinetic energy in transit. It is energy actively moving from one place to another, trying to fix a temperature imbalance to achieve a state called thermal equilibrium. Let's start with that metal roasting stick held directly in the flames. Metal is a solid, and solids have a rigid structure. The molecules inside that rod are constantly vibrating, but they are locked firmly in position. They can't freely float away or change places with one another. This diagram shows the point of contact. Fire injects energy into the rod's tip, causing particles to vibrate violently in place. Tracking from hot to cold reveals a domino effect. Hyperactive molecules crash into neighbors, passing energy straight up the rod. This direct physical contact transfer of energy is called conduction. It is the reason solid objects will inevitably pass heat into whatever they physically touch, like your hand. Now look away from the solid rod and straight up into the rising, turbulent air and smoke directly above the flames. Unlike solids, gases and liquids are fluids. The particles inside fluids are not locked in place. They are entirely free to drift, swirl, and physically change locations. In this diagram, heated air particles accelerate and push apart. This expansion decreases their density, forcing the lighter, hotter air upward. Following the arrows, a cycle emerges. Hot air escapes up, and heavier, cooler air sinks to fill the void, repeating the process. This continuous, rolling cycle of fluid matter physically transporting energy is called convection. It answers exactly why heat inherently travels upwards through our atmosphere. But what about the side of your face? You can feel the intense, glowing heat hitting your skin horizontally, entirely bypassing those upward rising air currents. This third path of heat transfer relies on a different mechanism. It requires no physical contact and no air or liquid to carry the energy from one point to another. Every object in the universe with a temperature above absolute zero projects invisible electromagnetic waves. A campfire is firing these waves outward in all directions, constantly at the speed of light. These electromagnetic waves travel straight through empty space. When they crash directly into your skin, the impact instantly increases the kinetic energy of your face's molecules. This mediumless projection of energy is radiation. Because it doesn't need particles to hitch a ride on, it is the singular reason thermal energy can cross the pure vacuum of space, from the sun to the earth. Zooming back out, we can look at the whole campfire. The hot metal rod, the rising smoke, and the glowing light are all part of one unified system of moving energy. Conduction, convection, and radiation are the universe's 3 tools for achieving one absolute goal: thermal equilibrium. Thermodynamics dictates that heat moves from high-temperature zones into low-temperature zones until the energy is distributed equally. But we have to ask what happens to the physical matter around us when it absorbs all of this aggressive incoming kinetic energy. Look at this side-by-side animation. As the particles in an object absorb energy, they move faster and collide with greater force. The impacts push the particles away from each other, causing the internal grid to expand and take up more volume. This phenomenon is thermal expansion. It is an invisible mechanical force stressing and warping the physical structures of our world every single day. Subscribe to Physics of the Tone to uncover how engineers account for these shifting dimensions to prevent our roads and bridges from buckling in the next episode.